Hi everyone, I am Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. In this lecture video, we are going to discuss about the solutions of linear programming problem using by Simplex method. So when you apply Simplex method, the decision variable is more than 2, then you apply the Simplex techniques. If the decision variable is only 2, then we solve the given LPP as graphical method. But the variable is more than 2, definitely we apply the Simplex techniques. So before that, we have some of the definitions. The first, what is the meaning of solutions? A set of variable x1, x2, etc., xn, which satisfy the constraints of the LPP is called solution. So what is feasible solution? Any solution to the LPP which satisfies the non-negative restrictions of the LPP is called feasible solutions. So what is optimal solutions or optimum solutions? Any feasible solution which optimizes the objective functions of the LPP is called optimum solutions or optimal solutions. So what is simplex method? So before we have some few definitions what is basic solutions. Suppose a system of m linear equations with n variable. Main condition is that m is less than n. The solutions obtained by the setting n minus m variable equal to 0. The solving the remaining m variable is called a basic solution. The m variable are called basic variable and they form a basic solutions. Then n minus m variables which are put to 0 are called non-basic variable. So what is non-degenerate basic solutions? A basic solution is said to be non-degenerate basic solutions if none of the basic variable is 0. So a basic solution is said to be degenerate basic solution if one or more basic variables are 0. So a feasible solution which is also called a basic feasible solution. Here we have two different variables. One is slack variable and the surplus variable. So what is slack variables? From the constraints, we add a sum of the positive quantity to the left side of the constraint and we make the inequality as equality. Then the adding variable is called slack variable. Similarly, we have some greater than or equal to constraints and we make this greater than as equation. We subtract a positive quantity to the left side of the constraint, then it's make it equality. Then the subtraction variable is called surplus variable. Now we solve the given LPP by simplex techniques. Here there are three inequations. Therefore we introduce three slack variables s1, s2 and s3. Before that we make it is all as standard form. So maximum is 4x1 plus 10x2 plus there are three slack variables introduced. Its cost becomes 0. Therefore we add plus 0s1 plus 0s2 plus 0s3 and subject to the constraints 2x1 plus x2 and we make inequality as equality. Therefore we add slack s1 and remaining cost becomes 0s2 plus 0s3. Likewise 2x1 plus 5x2 plus 0s1 plus we make this less than as equation using by second slack variable s2, then it is equal to 100. From the third inequations we add one more slack and it make it as equations. Finally all the decision variables, that is x1 x2 including the slack variable s1 s2 s3 are greater than or equal to 0. Since there are three equations with 5 variable, therefore 5 minus 2 is equal to 2 variables to 0. It is initial basic feasible solution. Now we form everything as equations. So yb is a basic vector, is the right side of the equations, s1 0 0 its cost, and yb is s1 s2 s3. It's a vector value become 50 100 90 and we make everything as here coefficient matrix, coefficient forms, then we form the table here. So from this here we put it the table, we make it the second row as 0 as the formations, we get the pivotal row and the pivotal column. the intersecting of pivotal and pivotal column as 1. Therefore we move to one more steps. We get the table here and we make some of the corresponding solutions. So finally we have this z1 is z value become 200, s1 value is 30, x2 is 20, s3 is 30, and the decision variable is only x2. Therefore the remaining x1 x3 becomes 0. Therefore the optimality, from this optimality it is reached as a positive. Therefore it is a 200. The value become x1 0, x2 20, and x3 is 0. So we get maximum is 200. We have one more problem using the simplex method. It is a minimization. So we convert the minimization maximization using by minus of maximum z. So minimum z is minus of maximum z, or maximum z is maximum z star is minus of minimum z. So we convert everything as equation. It is a standard form. So we introduce two slack variables s1 and s2, and how many basic feasible solutions? S1 is 1 and s2 become 3. So here the x1 x2 are 0, that is non-basic, and we formulate the standard as a table. We calculate what is pivotal element, then make it is everything likewise. What is z data? This is the data, this current is feasible, it is not optimal. We go to one more table and we get the positive z value. So the x1 x2 are only the decision variables, so x1 0, x2 values off. Finally we make it is, we need what is minimum value. So minimum is maximum of minus z, or minus maximum of minus z. Already we have the maximum value is 1, therefore it is minus 1 when x1 is 0 and x2 is 1/2. Thank you.